we're going to talk about some strategies for applying identities. So we've learned all of the trig identities already. We're going to be talking about how do we use them. You have the reference sheet in front of you. What are some strategies that we need to know? Well, use substitution is a big one. Factoring, rewriting in terms of sine and cosine, getting a common denominator, squaring both sides of an equation, and aiming for matching input angles. So let's talk about these one at a time. Use substitution. Use substitution jumps out to me anytime that I have the same function appearing with the same input, but with slightly different versions. So something like 3u squared minus 5u plus 1 equals 0 is going to be easier to solve, and then we can set it back equal to sine. So that's one thing that you should keep in mind. A second one is factoring. This equation looks pretty weird, but if you start thinking about factoring it, thinking about, okay, there's a 2x as a common factor, and I can write this as 2 cosine squared of x minus 1 equals 0. Now we can set 2x equal to 0 or this equal to 0, and that will make our lives easier. So consider factoring. Rewriting in terms of sine and cosine. So when we say tangent plus cotangent, well, I think of doing sine over cosine plus cosine over sine. And that ties perfectly, and this makes it easier, especially when we tie into our next idea, which is getting a common denominator. If we get a common denominator here, then we'll have a simpler expression to deal with. So getting the common denominator here, we see 1 plus tangent of x, 1 minus tangent of x. If we multiply this by 1 plus tangent of x over 1 plus tangent of x, and this times 1 minus tangent of x over 1 minus tangent of x. I should probably do that. Then we will get an easier expression to deal with. So sine minus tangent sine this is all over 1 minus tangent squared, and cosine times tangent, you should know, is sine. So now this is going to be something that we can do some stuff with. Squaring both sides of an equation. Sine plus cosine or sine minus cosine are not part of our sum to product rules. That's because if you square both sides of it, you'll end up getting a sine squared plus cosine squared in there. So there will be a middle term. Remember that when you multiply sine plus cosine times itself, it's polynomial multiplication. So you're going to get a perfect square trinomial. 25/16. So if we square both sides, oh, well, that equals 1. So setting up these options in advance by squaring both sides is something that it's not really obvious from here, but if you get used to sometimes squaring both sides of the equation is a good strategy, then you'll know, hey, maybe I should try this. And aiming for matching input angles. If I see sine of 2x plus cosine of x equals 0, well, I can either turn this one into x or turn this one into 2x, whichever one is going to be easier. I certainly think applying the double angle formula for sine is easier. Now we have something that we can solve using our second strategy, factoring. So matching the input angles is certainly a useful strategy as well. Some other tips to be aware of. These aren't quite exactly strategies, but like just general tips. Try Pythagorean identities before power reducing. I've seen someone do something with sine squared x plus cosine squared x, and then try to say, okay, this is 1 minus cosine of 2x over 2 plus 1 plus cosine of 2x over 2. And this will get you to the right answer, but is it the fastest way? Pythagorean identities are certainly much easier. And also, if you're not looking to change the angle, Pythagorean identities are going to be better. So try Pythagorean identities earlier rather than later. Scan the outputs of formulas. If I give you something with let's say 8 cosine squared of x minus 4, well, you should be able to recognize, oh, this has something really close to one of our double angle formulas. Rather than having to do something weird with cosine squared, you should be able to see, okay, this is the same thing as 4 times 2 cosine squared minus 1, and that's one of my double angle formulas, so this is cosine of 2u. It's much more common to take this and turn it into cosine of 2u than to go backwards, or actually to go forwards. Usually the formula is written as cosine of 2u turns into this, but it's much more common to see this and have to recognize that it's cosine of 2u. So be aware that you should recognize the outputs of the formulas as cosine of 2u or whatever it happens to be. Lastly, people are used to doing double angle formulas with something like cosine of 2u. But as long as there's some sort of multiplication going on inside, you can use a double angle formula. So this is the same thing as sine of 2 times 2x plus 1. So you can apply your double angle formula. Now, this is saying that u is 2x plus 1. So we're going to get the original formula is 2 sine x cosine x, or 2 sine u cosine u. But you have 2x plus 1 is taking the place of u. So this is double of 2x plus 1. So we use 2x plus 1 as part of the substitution. That's a big idea. That does mess people up a lot. You can use a double angle formula here as long as half the angle you treat as 2x plus 1. Same thing here. If you have sine of this, people sometimes recognize, okay, it's a half angle formula. But when we treat it as a half angle formula, we have to say that it's 45 over 2. We can't treat it as sine of 22.5 over 2. Because then when you do this, well, are we doing cosine of 22.5 or are we doing cosine of 45? If you've written it like this and you look at your half angle formula, it's clear that this needs to be cosine of 45. So just because there's not 1/2 or 2 as a factor inside the input doesn't mean you can't use a double angle or a half angle formula. Be aware that you can use these. That's it.